Hello, my name is Adam Langevin, the CEO of VLab Education, and today we will be diving into the concept of a precipitation reaction. In this case, we have our sample of silver nitrate here. This is a salt that dissolves in water, and we want to get that silver out of solution. So how do we do that? Well, one of the greatest ways is to use a precipitation reaction. This is a reaction where two ions, while they normally in water, they are more attracted to the water. If they find each other and they are more attracted to each other than to the water, they will come together and become insoluble. A great example of this is certain compounds that don't dissolve in water, like oil and water don't mix. Very much so, some solids don't dissolve in water. So what we can do is we can create one of those via this type of precipitation reaction, which will have been discussed in a classroom lecture, and then we can explore what kind of reactions can occur with different compounds. A student will be given a precipitation chart to pick the ions, pick and choose, looking at the ions, and it predicts whether a resulting salt is soluble or insoluble. And given that, they will make predictions based off of what they have here, and then they will go into the lab and test those predictions for themselves. So, just like any of these labs, if you want to fully reset the lab, we have a reset button here, and if you have questions about controls, we'll have the hand controller guide as well. So, let's begin. We have our solution of silver nitrate. So what does silver nitrate really look like when it's in a beaker of water? So if I were to click visualize, you can see floating around us, we have our nitrates and we have our silvers floating around. They do not, while it is a salt, they are separate. They have not come together in any way. So just to keep that in mind, let's do a compound. So now that we've done that, let's do one alike. Sodium fluoride. So what does it say? Add 10 drops. So I'm going to pick some up. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can then visualize what happens if you add sodium fluoride to this solution. So we actually know that fluoride is in our water, and very often it's done via sodium fluoride, as sodium is just like table salt. There's small amounts of it in water. You can see that while all of these molecules, these ions, they're floating around, but they're not actually interacting. They're in a soup of water with each other, but because the water is stronger than any interaction force, they stay separate. So what were to happen if, for example, let's reset our solution. So we are resetting the solution. We can just, if we needed to, we can always double check, for example. Now it's back to only silver nitrate in that beaker. I'm going to teleport over. Now, what happens if we were to pick something such as regular salt water? Make sure, does it work? Let's try this. There we go. So, we'll now add 10 drops. Whoa! See that? 7, 8, 9, 10. Look at that color change. Maybe something has happened. So, let's go here. Whoa, so what's happening here? Well, what has happened is we have taken the chlorines, these are chlorines, and they have found the silvers, and this bond forms, and they've all sunk to the bottom. This is an insoluble compound. They are no longer ions, they're no longer charged, and because of that, they fall right out of solution. While there are but what about over here? Well, not all of the atoms take part in the reaction. The nitrates and the sodiums continue to float around. And that's because they are considered what are called spectator ions. They don't actually participate. They don't participate in this reaction. So this is a great way to visualize, because a lot of students struggle with what is really happening at a molecular level when they see a color change. They think all of the molecules take part, or oh, this is always in there. No, they were floating around, and then they found a chlorine, and because this bond is stronger than that of water, they'll come together, and then they'll fall out of solution. But there's stuff that doesn't do that. Now, we have a total of solutions. We have a whole bunch of them over here, so let's reset that. And we're not going to go through all of them today. They are all done. I believe this one specifically, or not this one, I believe one of them needs a very specific edit that needs to be done. It's the NH4NO3. However, all of them are working. This is a simple demonstration to show that this is an excellent way for students to explore. As mentioned in all of my videos, our philosophy at VLab is to allow the student to explore and even pick things which are considered quote-unquote wrong. There's no real such thing as a wrong answer. It's just a new learning experience. If you picked, for example, NaF, and you added it to the water and then nothing happens, that's not just a wrong answer. You're learning that some things stay ions and they don't interact. It's still a learning experience. Even, for example, CaCO3. This is a compound where, for example, you can see that white at the bottom, though? You see all that white at the bottom? That's because calcium carbonate is actually not soluble in water. So if I were to take that and add it here, what do you think you would expect? Well, if it's not soluble here, that's just pure water, and then the salt's at the bottom. So we have our silvers, and it looks like the texture on this has not been updated to the new one. That's like a 5-second fix. But yes, so assume these are the old nitrates, the ones that we saw in the beginning. But it's all the same thing, as if it were the original compound. It was the original solution. It's the same thing because it hasn't gone in. But it's okay. That's part of the learning process, to allow a student to pick that and see what's really going to happen. A lot of our competitors don't allow that, or they just gloss over it because they want to show the real part of it. Well, all of it's real chemistry. So that's one of the big philosophies that that I really try to harp on when it comes to designing these kinds of more open experiments. And of course, we are also designing pre-lab introductions that the student reads to help them grasp the concept and give them a track when they do go into these labs. So thank you for listening. This has been our precipitation experiment, and have a wonderful day.